Here and pleasure to present alongside Mark the undertaking of the Dartmoor renewal. So just as a little bit of an overview and to improve everyone's geography of Devon, to be honest with you, this project was part of the government's Restoring the Railway scheme. It was the first Restoring the Railway scheme supported and promoted by the DfT, and its aim and its goal was to reconnect this section of line here. So this map is essentially from the 1950s, give or take, before beaching and before some closures. Lots of these lines don't exist anymore, lots of them do, however. So to familiarise yourself, we are approximately 15 miles north of Exeter. So the Exeter-Crediton to Barnstaple line, the North Devon line as it's known, still runs, has been running today. And the section that we were tasked to look to reopen and restore the railway was the link to Oakhampton. So from Crediton, there's 4 miles to a place called Culverts Junction, and then you've got a further 14 miles up to Oakhampton Station, and then you have a further 3 miles up to Meldon Quarry. And the line, back in the 1950s, used to run down here and join up with Tavistock, which is the link that no longer exists. So that's a little bit of history. The project has been split into 3 stages predominantly. So our mission and task effectively was stage 1, to introduce a passenger service to run a train every 2 hours with a view to commission this in October or November last year, 21. And the remit was a really open remit that all we were to provide was a train service from Oakhampton to Crediton in 25 minutes and from Crediton to Oakhampton in 27 minutes. That was the scope of it. How we went about and did that, I'm sure I'll come on to, but was left really open to a collaborative project team. Stage 2 was then envisaged that we ran an hourly service, and the times up there obviously got greater, which meant trains needed to travel faster, more efficiently. And then stage 3, which is still subject to future demand, would be to allow for the passive provision of freight to Meldon Quarry. And while we always had in our mind stage 2, stage 3, as we undertook stage 1, clearly, the initial remit was to open things most efficiently to allow the 2-hourly train service, which is really important when I come on to scope, when I come on to minimal viable product conversation. So you can see here a bit of a view. Everything in green up to Oakhampton was what we were tasked with reopening. The section from Culverts Junction to Crediton was part of the existing network maintained by Network Rail. Why do it, essentially? So there were so many benefits in terms of the business case of why we'd like to restore our railway to Oakhampton. Providing a direct link or restoring the direct link from Oakhampton into Exeter had so many benefits of growth, economic growth. There is a college in Exeter just right next to Exeter Central, which connected the Oakhampton students. Decarbonisation, for those that have had the displeasure of trying to get into Exeter at rush hour, it's not a very pleasant experience with the road network. This opens up the connectivity between Oakhampton, Crediton and Exeter directly into the centre of town. Tourism, so Dartmoor Line. This is a direct link onto essentially the mouth of Dartmoor. Incredible tourists. There is a bike route that essentially goes over Meldon Quarry. That has opened up massive links. Again, generating growth, all part of the 11.5 agenda as part of the DfT. You can see here also that we have major housing developments through Oakhampton, as with any fairly medium-sized town at the minute. It's expanding, it's getting bigger, and is part of future stages. Remit definition. So when we were asked as a collective, and I'll come on to the project structure in a bit, but when we were asked as a project collective how we can go about restoring the railway, opening up to stage 1, we all, as a collective, took a very long walk. To be honest with you, no more complicated than taking a walk. So this line had been closed to passenger services in essence since 1979. It had maintained a small freight capability and a heritage line capacity up until the early 2000s, and then it had ran a very, very occasional Sunday service and a Christmas service as well. But we define the remit by all taking a walk, so jointly asset managers, sponsors, delivery teams, and a whole combination of stakeholders took a walk. Now, for those interested in track, which I'm sure that's why I'm here, we found a whole plethora of components, some good, some not very good. But as part of a joint collective, we went and studied all assets. So track drainage, which I'm sure we'll come on to, earthworks, off-track assets, as well as many others. So you can see here in the left, that is a typical overview of effectively the track condition for approximately 75% of the 14 miles. So you've got predominantly 1940s, 1950s, 1960s track, which, while has been maintained by the heritage, has not seen regular maintenance patterns of what we'd expect now around. You have here obviously a longitudinal bridge, which is a bridge called Greenslade. You can see that fantastic job the heritage people have done to keep this bridge open, however, clearly as part of our upgrades. And you've got there a general overview of typical view of the vegetation, typical view of the off-track assets there. Just as a point of note, this used to be a two-track railway when it was in effect in the 1960s, and throughout the 14 miles, you can see where, to keep the single line maintained, they've moved from track bed to track bed effectively. We'll come on to some of the design parameters. It wasn't all bad. You can see here a section of perfectly maintainable track. So this was a high output trial in the early 2000s that was done up there for approximately a mile. And you've got an overview of some of the off-track assets. So this is a fairly significant earthworks cutting here that clearly was picked up as part of the remit deficit, needed further investigation. What we did then, so after we were all very tired and had a good deal of food from our very long walk, we went and plotted essentially all of the asset data. What we came up with was the current state of the railway as it is. So obviously as part of the funding challenge, as part of the business case, there were some significant challenges from DFT to ensure we're doing this efficiently. What this is showing is that we actually had a railway. We did have a continuous railway up to Oakhampton, and this is in the do-nothing state. However, noting that the times that we had to achieve the box times in terms of the stage one, we have a plethora of TSRs effectively, so 20 mile an hour TSRs, all due to track condition, level crossing sighting, formation issues, a whole realm of earthworks issues, but possible to run a train. However, not possible to meet the objectives in terms of box time. What we did then was we ran the TRU train, and that gave us some of the more dynamic areas and validating what we'd already walked. So we had a fair idea of what the track remit would be, but the TRU identified under load effectively the areas that we really need to focus on, why we need to focus on it. Also helped the conversation around funding, why we need to go and do these renewals. And you can see here, so we've got the good bit of high output there that they delivered. Then we have 4 satisfactory and very poor, effectively. And you can kind of see there that we're starting to look at 4 batches of red, which ended up being the track scope. We did this for all assets. Obviously, I'm here talking to the PWI, so I've heavily doctored this in terms of some of the track elements, but we did this for all assets, one of which we're going to come on to in detail. High-level scope that was identified at this point in time. Track works 4 sections of major renewals. This consisted of effectively nearly 15 kilometres of Cat 16, a small section of Cat 11, and a small section of rerailing effectively, totaling 17.5 kilometres of renewal that was driven out of this to achieve the stage 1 objective. We then, just touching on other assets, station work, so Oakhampton Station, needed bringing up to modern standards, but was a perfectly beautiful, actually, station. Just needed alterations, lighting, telecoms, and car park. Minor works to 21 of the circa 40 structures that were throughout. They were all assessed in terms of their capability and capacity for the line. Drainage works, which we're going to come on to in a fair degree of detail. Crossings, both user crossings and pedestrian crossings throughout the line. GSMR to enable communication for the trains. Earthworks, signalling works, and a whole degree of off-track works was part of the scope. So I'm sure you've all heard a varying degree about this. This was one of the first project speed projects, essentially, to be delivered. Lots of the savings and efficiencies were driven on the one team ideology. I've talked about all the stakeholders that walked in the initial part. They were taken through the process. Cutting costs by thinking differently. So some of the items around the remit in terms of we're looking at the box time. We're not looking at the end output of the remit. We're looking at what needs to be achieved. And if we can achieve that by a different means than we would do traditionally, that is what we look to do to save costs. Fast tracking through stakeholder approval. I'll come on to the team setup in a minute. And saving years from project timeline by cutting some of the unneeded process out of that, which I'll come on to. So one of the drivers, if you like, that actually gained some real efficiencies on this project and is really interesting in terms of some of the track undertakings that following the times that I mentioned to achieve stage one, the initial line speed configuration as part of our remit was basically confined here. So what we were looking to do was upgrade this section, remember is on the network, so Crediton to Culverts Junction, upgrade that from 40 miles an hour to 55 miles an hour, and then provide a 55 mile an hour railway essentially up until Stamford Courtney, and then 40 mile an hour into Oakhampton. That was part of our initial thinking. That was pretty much what the existing railway was. And if we hadn't applied speed principles, if we'd have taken that on face value, we'd have had to deliver a fairly significant degree of renewals between Crediton and Culverts Junction, spending lots of money, to upgrade this section from 40 to 55. And some of the thinking, some of the workshops, some of the collaborative work that we've done actually said that if we leave this at 40 miles an hour, that track is perfectly maintainable. And actually, if we look at spending no more money, but upgrading some of this area of track, which is one of the the longest straight, I think now in the Western network, to 70 miles an hour, because we're going to renew it anyway, at no extra cost, we can provide the time, effectively, time that we've set out in the agenda. And this was one of the things that bore an awful lot of efficiency in not doing significant renewals on that section, grading this in terms of some of the alignment to 70 miles an hour versus 55, and achieving the end output. However, if we were given this just as a remit ourselves, blindly gone and delivered, we wouldn't have made that efficiency. And that bore true to lots of the other assets, but is a perfect example, speaking to you find track people today, of what we can do if we go back and give ourselves some scope in the early reading. Project team, cross-industry collaboration. This looks very busy as a slide. Essentially here you have the Network Rail project team hub. So what we set up is a hub and spoke model. So we had the hub project from Network Rail. They had, best way I can describe it, lots of plates spinning in terms of deliverers. So you can see here we've got Network Rail Works delivery, who I was very proud to be a part of, delivering across the scope of stations, track, structures, off-track, and signalling, and level crossings to a certain degree. You've then got COLAS, Limbrooks, ECUS, and the consent team from Network Rail providing support, all feeding into that hub and all integrating into the hub. We work really, I cannot understate how closely we've worked with everyone on this slide. And what's really important is that each one of these had an empowered decision maker. So I probably count on both of my hands the number of people that had real power, real justification to go and make decisions and go and make things happen on this project, and that was key to its delivery. What I will now do is hand you over to Mark, who is going to give you an overview of the drainage challenges as part of the Oakhampton remit and scope.
Thank you, Dan. So, as it says on the screen, member of the PWI, thank you for having us here today. I'll try not to bore you to death with words. I think the first file I've got is a number of words, but I'll try and just give you an overview and a feel for some of the things that Dan described. So the initial walkout through to the actual definition of what we need to do, and then into the actual delivery of the work. So lots of pictures. There's some yellow plant, which is always nice. Press down.
That one there. That one there.
Yeah. Right, so you'll be aware as track engineers, as a member of the Permanent Way Institute, that getting the formation right is critical for any longevity of track bed, performance, joints, your insulated rail joints, things like that. So at an early stage, for me, it was about combining into bigger systems. So Dan's talked about the speed principles, about doing things that collective. But for me, as an engineer, as someone empowered, as Dan said, as an asset manager, one of the things that I really wanted to do was take a look at what was there, be involved in the process, and then actually be involved in the work itself. So I think the first thing I did, and I remember this, the long walkout, it was 3 days of walkouts. I think we did 4 or 5 miles a day, plus a bit more on the end. And you know what? It nearly killed me, but it was worth it. A long drive back to Exeter. There are no hotels on the network rail system near Oakhampton. So luckily there will be now. So we get the train. So prior to that walkout, we looked at the two-chain plan. So desk studies, really important. Not an earthworks engineer, but if I was, I'd be looking at site investigation, ground investigation. Drainage is a strange hybrid between track, between earthworks and civils. So for me, doing the desk study, which is looking at in terms of source records, was really important. 1951, the records that we had, which are over in the office over there, Western House. So just looking at what was there, I mean, you'll see already that there's now one line, got a single line through here. This is North Taunton, but you'll instantaneously recognise things like culvert, and there's another culvert at the other end, which is just off the shop. So just looking at things like this, picking up those key bits of detail, so that when we did the walkouts, we could identify these. Not all of them were in good condition. Landowners, especially when you've got a railway that's been left for 20 years, tend to go a bit native and a bit rogue. So we found all sorts of things wrong with culverts, pallets in front of inlet head walls, all sorts of things that shouldn't be there. But yeah, just the need to do desk study, just I cannot overstate the importance of that. That led to the walkout, and that led to finishing up one night in March 2020 at Oakhampton. That took then the form of a list of observations, which I've kind of put into actions at the end. So too small to read, I realised, but just things like, does the culvert need a handrail? Is the track drainage fit for purpose? Is there something else that we need to do? So for example, it's drainage obviously. You'll just see, eagle-eyed amongst you, chambers that are in the 6-foot between 2 running lines at the station. So these are all covered with timber sleepers. Now, timber sleepers aren't any good for us in terms of manual handling, doing the inspections. So these are all now raised. They've got blue lids. They're visible. And yeah, that's Oakhampton. So just in terms of kind of then moving on from that initial desk study, the observations, this is then looking at kind of doing some of the actual work. So this is just towards Oakhampton. The railback, can't overstate how important that bit of kit was for our job. Drainage ditches aren't actually that bad most of the time on this line. They look like this. This is before work, so things needed to be cleared, but they were generally in reasonable condition. Now, for those familiar with the railback, it's got a great suction capability, and it's got the ability, more importantly, to discharge material from the side. So you can take material from where you need it to be gone to somewhere else. So that railback, January 2020, was really, 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 21, sorry, really, really handy, and just saves us so much time and effort, manual handling, because some of these things, come on to in this slide, these are all concrete troughs. So trough drains typically, I think the southern region must have had an obsession with concrete trough drains, because literally 14 miles that Dan talked about in terms of track work, probably had 12 miles of trough drains with them. So all of the cuttings had a trough drain. We think probably because it's through granite, it's the Dartmoor incursion, so you've got very hard material, and it's probably very expensive, would have been, to dig down into the underlying material. So granite is perfectly acceptable to run water along the top of. They formalise with the channel, but as you can see, when you don't do maintenance to a drainage asset, this is what happens. So when we turned up, and I'm really sorry, I didn't get a picture just as we turned up. I was searching the archives on my computer, but the water level, which you can totally see, is kind of up here at Sleeper Top, and over there you can kind of see this line on the bridge here. So the water was sat and just stood all across the formation. Obviously when Dan's team did the track work, that would have been disaster. A, you would have been working in water, and B, long term, that's not great. Track doesn't like water, so just doing that amount of initial railback work saved so much in terms of the life of the asset. I think, Dan, that's the re-railing section, isn't it?
Yeah.
But yeah, covers are clearly not fit for purpose. So a little bit more on the railback there. So again, this is the same cutting, but you can really appreciate here from the amount of debris just how buried these trough drains were. So these were full of sediment, organic material, but getting them back really has made a difference to the formation. So it's not perfect because these are 60 plus years old. When you look at asset life considerations, when you look at design life, there are things that we will clearly have to do, but we've tried to adopt the adage of, if it's not broken, don't fix it. To maintain it, obviously, that kind of is a big caveat there, but these things work, water's flowing, so again, it's just about taking that engineering view of what needs to be done to meet the ultimate output, which is run the 2-hourly service, then run the hourly service. But this is just, I just love looking at the slides, it's great. Just see the amount of debris that's gone. So culverts and channels, again, you can see now, channel on the left-hand side was completely full to the top, with leaves, with sediment, with debris. This culvert was full, there was debris up to the top of it. So a lot of it has just been some real, I guess you describe it in the asset management world as heavy maintenance, which is an awful term, but it's just doing what everybody's forgotten. So drainage really has been quite a key part of this project. It's unseen, as often as you can see here, kind of off in the edge of the formation somewhere underneath the embankments, but when you get it wrong, it comes to bite you. So what we tried to do with this work is try to get all of the things done before we started running train, because A, it's more efficient. When you have a railback and RRBs running up and down the line, that's a hell of a lot more efficient than it is to do it in midweek nights, weekends. I think you probably get 3 or 4 hours a night when you take possession, the line blocked. So try and get as much work done up front as is possible would definitely be something that we'd look to do again on another railway project. So, and yeah, it's about the team. So my team were heavily involved. Dan referred quite clearly to the fact that the asset owner, the asset managers were involved. My team went down, we did some surveys of the drainage system. We really helped. There's obviously lessons learned. Shears has been involved in. There are things that we could have done differently. We acknowledge that. But just, for example, here, just on the approach to Falford, those 2 drains were existing, raised them, provided blue covers, made it safer, easier to inspect. We did replace the cross drain there, because one of the first things that you do is the cross drains, especially because they're going to interact with track support zone. So I think there were 8 cross drains that we ended up replacing. All of those would have been an absolute pain if we'd have had to do them post the track work. So you'll see here are the rails laid down for the new track. All of that got ripped up. UTXs went in, and that was something that I was really clear with Dan about, was that actually some of this is not only about the achievement of the end goal, but about alignment of work. So most efficient time and the best time to do UTX work is when you've got the track out, rather than taking it out retrospectively, splitting the rails, moving the sleepers. And we've got, hopefully, a better formation because it's more uniform, it's more stiff. So, yeah, about the team. I have to get a yellow book in every presentation I do, so that was book 89. And then, yeah, now where we are in terms of trough drains is looking at some of their conditions. So you've seen in earlier slides, poor condition of some of them, the absent nature of them. There are places that look much worse than this, but what we try to do is come up with the right solution for the project. So instead of just taking off all of these and replacing them, we've had to go through a lot of work with a company called Lineworks, who have helped us out. So I talked about the fact that every cutting, most over the 12 miles track, we touched, had a trough drain. I could not believe, I thought there was probably 2 or 3 types of trough drain. There are 11 types of trough drains that we have found in that section of track, those 12 miles. You couldn't make it up. And they're not even slightly similar. They're all different cross sections. They all have different flow properties. And of course, unfortunately for me, who's got to pay for it, they've all got different size lids. So we did a lot of work in the background, a lot of basic principles with concrete, all the designs, rebar, things like that, with our supply chain. And we've now come up with this new, slightly smaller, if you, how do you go back now? Ah, there you go. So you'll see that these are quite a lot longer than the new ones. The reason for that is because the weight, the manual handling risk, these are going to have to be picked up by staff out there on the front line. They want to inspect the drain, they want to replace them, and also for our work delivery colleagues who are going in to do this work as part of a future phase. These had to be smaller. We can't make things that are 40 odd kilos now. These are circa 20 kilos each, I think 17 to 20 kilos, but helped a small, medium enterprise business, really helped us. I quite like the numbering system on the back. I didn't come up with it, but each one is now numbered on the back, so that you can't sit it from the top, but each one is numbered underneath. And yeah, that's the program of works that goes through in place. And it just gives you kind of making sure that we've got commonality. This is where we're looking to do this work. So later on this year, we'll be in there with RRVs. I think maybe with the rarevac, we get it. Just replace these covers because they present a risk to our staff in the short term. So we've got mitigations in place. We've got covers that are there temporarily, but we need to get back in there and do other stuff to those trough drains. I'm really proud of this. 2 days earlier this year, myself and one of the surveyors from supply chain, so on-site, helped us massively. We've been on another long walk, so not only have I done the initial stage, at this stage, spent 2 days walking the whole lot, and 2 days the whole line is really tight, by the way. If you ever walk the line again, if you walk the line, do it in 3 days. But we've surveyed everything, so we've surveyed drainage, catch pits, culverts, everything, so that we can get that into ellipse. Critically for us as business, means that our maintenance team have got access to it. We can share that data with outside parties, and we actually now have a really good record of what's out there. So you'll notice on here, upper levels, inver levels, things like that start to mean that we can do calculations on flow, start to work out catchment areas, the capacity of what we've got. So there's a lot to do, as Dan said, and it's probably worth remembering there was a railway here already. If this was new, we would have started on first principles, what do we need in terms of earthworks, what do we need in terms of drainage, and worked out that way. We're backwards engineering here, if you like, taking what's there, cleaning it out, working out what's there. But yeah, and he had to have a smile in there. I had to find a picture with him smiling. So I think then, nope. really get better at driving them out. And then just phase 2, so Dan talked about stage 1, which is the 2-hourly service. Phase 2, or stage 2, was the hourly service. So that was introduced in May this year?
Yeah, May timetable.
Yeah. May. So one of the things we did identify was particularly poor drainage system in the cutting just on the approach to Ballingford Viaduct. So COLAS and ACOM, so part of the SRSA Alliance, helped us out, did some design work, and I've ended up with, I should say, a new drainage system. So this wasn't done as part of the first phase of work, stage 1. This is stage 2, but just see that when we work together, we can get things done. It doesn't have to be all done at once. That's the traditional view of project, do it all, do it once, especially if you start to track back into BR days. When they did a bit of work in an area, they did everything in that area, which is great, but it's not always possible now. We've got to run a train service, and I think we've probably moved on a little bit. We've got to run a reliable railway, and we've got to remember who we're doing it for, because all of this stuff is to enable the formation to be stable, good track quality, don't spill your coffee, so that people get a good experience. We can run the hourly service at 70 miles an hour. So all of these things feed back up, and I'm always trying to be clear with my team. We are just a little part of the bigger system. We've got to remember that. Best engineers I know think about the system. So, parts, delivery.
And just, I'll try and, just going back to this and just to label, this was all part of the stage 2 work. So, as Mark described here, what we had here, come opening day, was suboptimum, substandard drainage system, I think I'm fair to say. We mitigated that via a TSR, a planned TSR that was all in line with the box time. And then as a staged approach, we'd already agreed the access with the train operator as part of an integrated team to go and deliver this upgrade, then to go and achieve the hourly service. And that's a really important concept, that when we did open in November 21, that there were still areas of various different assets that were suboptimum. However, we had a staged approach to go and achieve the hourly timetable, and as and when stage 3 comes, we'll have a staged approach to go and enable freight as well. And that, you know, to drive the excitement of the project, we opened. To drive the excitement of the project, we then went to an hourly timetable, hopefully, obviously, because I'm from Devon. That will continue into a stage 3, stage 4, and so on. I make no apologies to getting excited about delivery, and I appreciate there are design people in here, but I make no apologies. So essentially, as I said in the introduction bit, we had just around 11 miles of renewals to deliver. That was a real challenge, as you can imagine. It's a fairly significant length. It was split into 4 different sections. We also had to work around the challenge of being very late to the party in terms of some of our requests. So as lots of you will know, if you're requesting engineering trains, if you're requesting 22,000 sleepers, if you're requesting a tamper to be locked in for effectively 2 months, and 24,000 tonnes of ballast, and lots of other things like that, often that is booked well in advance. However, as part of this, we had a significant challenge on our hands, and working with SCO colleagues nationally to go and make this happen with rail drops was an incredible effort from everyone in the supply chain. One step I have missed out here is in terms of the design work that was done by AECOM and the internal work delivery engineering team. An incredible bit of work to ensure that we are aligning the track to the revised line speed, that we have got our assurance correct in terms of this is actually a railway. We haven't got years and years of TRU data. We don't have a lot of history about how it's going to perform under load over the course of the first month, the second month. An incredible bit of work on that. Also, managing the alignment through different assets. So we've got user crossings, we've got marked drainage that we were very conscious not to bury again because we just uncovered it. Earthworks assets where, prime example here, down at North Taunton, where we have not a very good earthworks cut in here, we were very conscious that we've actually got quite a bit of room here to get away from that significant hazard and make that less of a hazard for the railway going forward. And areas like that AECOM and our internal work delivery team work through, over 11 miles at speed, at pace, was a real challenge. I get really excited about the delivery. So we had 4 renewals. How we split that up is essentially 1 per week. So they vary in sizes. The longest was approximately 6.5 kilometres, and the shortest was the run out of Oakhampton, which was around 2.5 kilometres. So we attacked them week on week, and as I said around SEO resource, we were very conscious that renewals cannot stop because of Oakhampton. So we avoided weekends to use a significant degree of resource, because we knew that would cancel effectively 5 weekends worth of work on the network. So how we delivered this was starting on the Monday morning. We essentially delivered that renewal through that week, and then we got everything back to Oakhampton Station, and 22,000 sleepers that you see there basically used it as a material handling facility to go and restock all the trains and then go and start again on the Monday morning. Now, the risk of that is if one of the weeks fell behind, it would have a negative impact to the subsequent week, get behind on the programme, get behind on delivery, and get out of kilter. So that didn't happen through some good planning, some good work. So we started at the low mileage end and worked our way back to Oakhampton effectively. RDT train dropped all the rail required for the 11 miles in prep, and that was moved to the side, like you can see here. And the main compound was established around about a mile outside of Oakhampton, and then we had 4 satellite compounds for each week's delivery as part of the track. So the old track was cropped into 15-foot sections, and it was moved to relevant places along the line where there was space to allow that. That then enabled dozing, scarifying and whacking to be undertaken, and any soil generated stockpiled in strategic locations. You can see here some drone footage, so the team were working down there. Very rural, communication was key, so we set up back-to-back communication through the whole 14 miles. Rail moved from the CES into the formation via the Culverts TRTs. Being a single line, the NTC earned its money. I have absolutely no doubt about that. So you can see here a view from the back of the sleeper train, and they brought the sleepers down onto the back of the NTC and laid from low to high mileage, high to low mileage in terms of the renewal, and then migrated back up to Oakhampton, if you imagine that. And then you've got the NTC, which has laid the track. This is just outside North Taunton again, on one of the straights there that you can see. And then various follow-up work, so all the ballast was dropped, brought into the network, brought in from the network, and then tamper locked in as well, and tamped our way up to Oakhampton effectively. Really important, we had so many different options here. We could have taken the NTC back to Doncaster every week and restocked it full of sleepers, brought it down, but that meant a reliance on the network, a reliance on it coming back, all out of our own domain effectively. So we had everything locked in, is the best way to describe it, all under our domain to go and deliver. How do you keep track of 11 miles worth of renewal was a real challenge, and the amount of stakeholders that I presented on one of the initial slides, lots of people wanted to understand how we were getting on at various different stages. So some of you might be familiar with the live worksite reporting app. We basically tweaked that to provide a time chainage accurate report. So essentially, the track renewal was split into 4 different elements: scrapping out, bottom ballast and dozing, sleeper and rail in, and then the top stone. And you can see here that that was taken within the first week. So this renewal here, we essentially got to top stone complete, and that was where we were planned at the end of the first week. Brilliant, all on track. And then we get to, I think it's midway through the 3rd week, you can see here that we have actual completion, and we have planned completion here. So you can see here we fell a little bit behind on relay 2, some of the top stone, and people could see actually us moving along and where we were supposed to be moving to. And one of the key bits was it was really simple. All we asked was that every 2 hours that the team reported where they were in terms of scrapping out to the chainage. And then this updated automatically on Power BI. If you got really bored at 3 a.m., you could just see, wonder where the guys are in terms of scrapping out, and kept everyone informed throughout. And something that if we do significant renewals again over a considerable mileage is really key to keeping track and ensure you're on progress. Other assets, so the 11 miles worth of track I've talked about, Green Slate Bridge, which was the longitudinal timber bridge that I pictured in the first instance. That was a significantly weak bridge, had a TSR of 5 miles an hour on it when we started. That was given steelwork strengthening repairs, and the longitudinal timber bridges replaced as part of the subsequent work after the 11 miles. GSMR masts, 5 of them throughout the route, that were all erected by Limbrooks at various different locations to provide back-to-back communication with the trains. Platform rebuild at Oakhampton, actually, really nice station there. However, the platform was rebuilt, modern standard, tactiles, appropriate crossfalls, and the station was upgraded as well. Lots of other off-track work, lots of drainage work, all undertaken. Operational readiness was a real significant program consideration. So when we reopened the line, the drivers required training on that line. That training was over a fairly significant period of time because they had lots of drivers to train up. It wasn't just he'll work or she'll work on that day and we'll be fine. We had approximately 40 drivers to train, and that was over around about an 8 to 10 week period. What we actually did is we did that concurrently with a lot of the programs of work. So we did the track renewals clearly because we needed that to enable the driver training to commence. However, we implemented speed restrictions and undertook the remaining work in essentially possessions of an evening and worked around driver training to enable them, GWR, to provide a full suite of drivers from day one, which was really important. And that saved a lot of program time. That saved essentially 10 weeks on the program. To give some assurance, blanket feeds were implemented and we ran TRUs, follow-up TRUs to assure ourselves that the track was good and fit. Contingency plans, managing of operational risk and working really closely with the ops team, and special opening events to create excitement, because there was lots of excitement, through resident stakeholders and everyone else. So here's a little bit of the timeline around the project acceleration. So you can see there that we essentially had funding agreed and announced in March 21, and then 7 months, 28 days until the reopening. I can't stress how working concurrently during this period of time, ensuring that we were geared up, that we had our plans, ensuring that we knew what asset management was, and at the end of the day, paid dividends. So when we did get the green light, that we essentially rolled into the program. And that's all about speed principles. That's all about some of the pace principles as well. And then moving on, reopened as a 2 hourly service. And then, as Mark alluded to, we achieved the hourly service as part of the May timetable and achieving the box times as well. Challenges, you've heard loads of good things about Oakham. Some of the challenges that were on this project, the accelerated design did introduce some risks that needed to be managed. So jointly working with sponsors, RAM teams in terms of some of our track bed investigation and the output from that and what our initial remit was a real challenge. However, we provided some assurance around that and the entry into service documentation. Ecological constraints, so presence of dormice. We had to work with ECOS significantly throughout this project to ensure that we protected their habitat and that we had appropriate mitigations in place aligned with Natural England. And the procurement and a project structure that I talked about. So fast-moving project, lots have changed. That hub of a project was really important to ensure that all the deliverers knew what they were doing, that they were integrated, that we were integrated with GWR. We used local internal resource where appropriate, and that was really key. They have the ability work delivery to react in lots of different circumstances, and utilising the frameworks and the contractors to ensure all the spokes are working differently. What I will say, I'll give it a plug now. I could have just played a load of videos from dartmoorline.com, but all of the works was uploaded essentially weekly by the comms team onto a website. Videos there, generating the excitement, generating communications with stakeholders. It was a joined up transport system, so we've got the rail link here, so buses linking with the timetables, linking with the trains, which is a really important concept, and I've talked a little bit about speed principles there. Minimal viable product, which I touched on, the real key drive to Oakhampton, as I said, around 2 hourly and progressively working to that end state was really important. And that is us, and I welcome any questions from either in the room or online.
We'll start with one online, which was from Joe. You mentioned a number of contracting organisations involved in delivery of works and then our operators as a hub and scope. Can you please explain the CDM arrangements you have on projects?
Yes, so a number of contractors provided lots of different assets. So we treated it like a live railway, just like a possession like you normally would. There were no third-party rules. We integrated our works with West Planning and treated it as a possession, is the first and most important thing. The hub was the hub, essentially. So all of the CDM arrangements and integration flowed through that hub project organisation. They were key, clearly, and without their aptitude, is what I would say. We've all been having our RVs cross into each other. I think it was really important that the track works had the place to themselves while they were doing the track work. So basically, while we were delivering 4 weeks and we had 2 weeks either side of that, we essentially, the track organisation, signed that and had that, and no one else was allowed in. That allowed then the more integratable work to come in and be integrated in terms of project delivery. There was one global CDM plan, to answer the question directly, but integration meetings were held weekly. Everyone was ensuring they weren't tripping over each other, weren't going in their domain, and then each of the principal contractors in their own domain. Does that answer the question?
I hope so. It was online, so maybe Joan will speak up.
Yes, I can hear. Yes, thank you, Dan. Yes, so it sounds like you had multiple principal contractors, and then you had to manage the interfaces in the centre. So I am interested in one further thing, and that is obviously the CDM is all about the identification and management of risk. So how did you make sure, because you had different people working there, that everybody understood the key risks, without getting into tons and tons of paperwork? How did you manage all of that?
Yeah, so we had a global project hazard log, is what I would say. So that project hazard log, which was owned by the hub again, and the DPE effectively across disciplines, was briefed out at all the integration meetings. We ensured at those weekly integration meetings that everyone understood where everyone else was, and was also mapped out. So one of the initial diagrams that I said, everyone's asset failures, if you like, so let's just say the sleeper wasn't very good, that was mapped out and was assigned to an owner so we could see it visually, because over 14 miles it's very difficult, as you can imagine, to place everyone and ensure they're not going to trip each other up. Hopefully that answers the question.
Yeah, thank you. Yes, thank you.
Did COVID adversely affect you?
Yes and no.
Yeah. Yes, it had its challenges. Significantly, what I would say is the site setup and compound setup was, for those that went there, hopefully you'll agree with me, was 11 out of 10, to be honest with you. We set it up in a structured way where the hub office, if you like, which was just outside Oakhampton, was a really good setup, and then we had satellite to manage that as a point of entry was really important. It switched everyone on and helped manage, we had lots of space, we made provisions in terms of COVID, so everyone was working safely. Obviously, as we went through the project, various different waves of COVID came and went, but we had that initial setup that meant that we were comfortable, that we had enough room for everyone, we were comfortable that it was the right facilities, and, it set the tone for the project. Hopefully you'll agree. Yep.
I mean, you had a lot of places of dropping into the affect the supply chain. Did they arrive when you wanted them to arrive?
So I didn't quite make clear, those are the trial ones.
Yeah.
The lids that we've put back on temporarily are the ones that were already there. So we don't know yet.
But you have new stuff delivered to site. So what I'm trying to get at was the stuff that was delivered to site adversely impacted? So in other words, you're standing around and arrive and someone said, sorry, mate, COVID, come back next month.
We didn't have too many, just thinking back now, we didn't have too many deliveries or raw materials that were affected in that way. I mean, obviously the track, a lot of the things came from SEO effectively, and while we had to make different arrangements for them to come in different means, we weren't adversely affected. Things like train drivers and, it's more the normal running of how you run a renewal. So, no, we weren't massively adverse. There was no one thing that I can think that went, oh my God, it's not going to come for 6 weeks and we've got a real problem here. And by the time we started the project, COVID working arrangements was, in progress, if you like, and it's become kind of business as usual again.
Okay, Joan's got another question online, so Simon, do you want to read it out?
Well, if Joan is able to turn her mute, it's able to follow up.
Yeah, so my next question is about CSM, and I was just wondering, how was this project categorised under CSM?
It's a good question. So I believe it was interoperable, and in terms of an entry into service checklist, I'll have to probably pause at that point there. But yeah, that was my understanding, but it was a little while ago, so I'll have to...
It was significant, I presume, Dan, yes?
I believe it was non-significant, but...
Non-significant. All right, that's interesting, because the last project I worked on with ACOM was on Northumberland Line, which is similar to this, and that absolutely was significant.
Okay.
Yeah, I think one of the reasons for that is, in terms of railway system, it was not very complex, so there was, a lot of volume of track renewals and a lot of drainage, but there was very little signalling.
Correct. Yeah.
So I think the signalling sometimes, drives the complexity of the project, and here a single line, very simple.
And the fact that the asset already existed, albeit not in a network rail state, and there was already a track there was already effectively a signalling system in place that needed to be revalidated, but wasn't creating a brand new, though it is a new asset, a brand new asset from concept.
Okay, thanks. Thank you.
Nick Millington's got a question.
Nick, would you like to come in and ask your question?
Nick Matthews, I haven't risen to such grandeur yet. Sorry about that, gents. Yeah, I'm just curious about the lessons learned from the project, and if you did it again, what would you do differently?
If I did it again, I think probably, that is hard. But I think probably we would have had a little bit more time and probably would have pushed back to bigger DFT type stakeholders that actually give us a bit more time. As much as it's been a pleasure and it's been a privilege, it has at times been constrained in terms of getting things done, signing things off. Dan alluded to a lot of those processes and concepts that actually they were enhanced, they were sped up. It's not to say that we go back to the traditional, this railway will be ready in 10 years' time and leave it with us, we'll give you a perfect railway, but I don't know, perhaps I would have wanted a bit more time.
Just for me, I'd have probably paid a lot more focus on some of the non-complex assets, because they have tended to be the ones that are actually more difficult. So, organising 11 miles worth of track renewal, incredibly complex, incredibly involved, and drew everyone's attention. actually some of the vegetation management, some of the more off-track disciplines is actually where, maybe a little bit more focus should have been applied. And, vegetation management is perceived simple. However, it's one of the things that I probably have spent more time focusing on. Thank you.
Gary?
I'm a Simon and I both know are the engineers, and we're very focused on the final product. So I'm quite interested in your view on clearly you were working within a very restricted envelope of what's possible. To what extent would you stand by the decisions that you made and the viable railway? To what extent you made compromises that have shortened the life of that railway, and you're going to have to go in the back and make further interventions in future?
Absolutely. I was expecting that sort of question. So I stand by them. Like, I'm an engineer, as is lots of the people that walk that. Pragmatism and understanding of the railway system was absolutely key to making some of the compromises and some of the decisions we made, first and foremost. Our objective was to run a train from Crediton to Oakhampton safely at a certain box. Now, how we defined that remit was a very, very long process, not in terms of time, but a very challenging one, because everyone has a different perspective on what being pragmatic around the scope is. Okay? And I'm very comfortable that while not everyone will agree with the remit that we ended up for stage 2, stage 1, and subsequently stage 3, that we all came to a consensus together as that big, busy org chart, that was the right thing to do for the railway to enable the reopening. So I have absolutely no doubt, I'll pick on Mark, he's stood next to me, that Mark would have absolutely loved a 450 diameter, massive, great big drainage system on both cesses down on Oakhampton for the whole 14 miles. I have absolutely no doubt that would be his objective. However, we need to be pragmatic in terms of that if we would do that, it's highly likely we wouldn't have reopened Oakhampton. And doing it as the staged approach and the managed approach via lots of good engineering assurance was absolutely key. Are there challenges? Were there lessons learned? Absolutely. I'm not going to stand here and say there weren't things that we probably would have done differently. However, we've provided project output in terms of the stage 1 times that we provided the stage railway. Then we've moved and done commitment of it's been popular. That's one thing I didn't say. It's been incredibly popular, and within the first 5 months, it's pretty much achieved its annual. So building on that, we've then gone to stage 2, which is the hourly timetable, and we've done the upgrades to suit. And that's not going to be left for the next 30 years, and then we'll come back again in 30 years' time. That wasn't part of the business case. Asset managers and part of the project will continually have to take this, renew items, refurbish items, and I think that's key. We didn't build a railway. It's not a railway that has a 120-year design life and will come back in 120 years and renew a bridge. That wasn't the objective.
And I'll add to that, Gary, that kind of from the asset management view in terms of long term, Dan's right. I don't know whether I would have liked a 455, but I would have liked a new drainage asset, new access points. I would have loved new stuff because it's easier to get value out of it. It's easier to do less inspection, less maintenance. But to be frank, as Dan said, we would have never done the project. So it was quite, I had to take a real hard look at myself and go, actually, my normal expectation, a little bit like the Sutton Bank project, a little bit like the Gwet project, was some of these things that have historically happened in the recent past where you actually kind of go, I would like this, I want a new cross drain, I want a new system, I need some assurance that it's going to last for 60 years or 120 years for earthworks, for example. That wasn't the case here, and that kind of, I would say that threw me at the start, because I thought the normal project definition stage is, right, tell me what you want, write it down in a route requirement document. I'd like a new drain here, a new drain here, and a new drain there. You go and do some design, come back to me, I'll sign the design off, you go and build it, we hand it back, job done, 60 years design life, crack on, as long as you maintain it. That didn't happen here, and it was a lot more focused on me as an engineer, my teams, people like Dan, program manager, who's an engineer really, but just looking through actually why were we doing that bit of work. So for those trough drains, the lids definitely need to be replaced. But those trough drains have been in there for 80 or 90 years. They were still working. Yes, they needed to be maintained. But why did we need to rip out something that was perfectly adequate and was serving the function, and will probably serve the function for another 60 or 80 years? But it comes down to inspections. So we've got to do more inspections, and we've got to accept that I've got assets out there that won't last for another 60 years. And that, as Dan said, I've got 7 or 8 items now in my CP7 work bank and CP8 work bank, but just becomes another part of the national network that has to be managed in accordance with the risk. Because although it's important, it is a branch at the end of the day. So
I don't want to answer the question again, but that site at Fallowford that Mark showed as part of the phase 2 is a perfect example why I think I'm comfortable that, you know, we knew that the earthworks on that site had to be done before we opened. Absolutely, red line, it will not be safe unless we do that element of earthworks. So we absolutely did it, and we knew that was critical to entry into service. Absolutely. However, the drainage system, discussed with asset management, actually, you know, we're not going to get an opportunity in this programme to reopen to go and deliver that drainage scheme before we reopen. So what can we do? We implemented a TSR, we implemented assurance arrangements around that until we got to the stage, in stage 2, where we actually undertook that upgrade and then removed that TSR. That's really important, and that's, in my opinion, a pragmatic view of what this project was all about.
thank you for the question.
Hey, have you any questions?
Yeah, there's 2 online. First, Richard, and then Mark.
Richard, you've got a question. Would you like to come in, please?
Thanks, Giles. Yeah, it's a question about the longitudinal bearer bridge, which you've got there. So I was just wondering what the thought process was with regard to replacing and upgrading it. I actually missed what was done, but did you consider the options of replacing like for like, or upgrading the actual design, or changing it to a ballasted track? I see Mark has put a couple of answers on there, but it'd be good to hear kind of the thought process through it.
I think that's you, Mr. Gibson, is it?
Hello, Richard.
Yeah, hiya.
So the Longitudinal bridge at Greenslade was, we did significant steelwork repairs to the longitudinal steelwork elements, and then we replaced, not in a like-for-like arrangement, but in a significantly upgraded longitudinal timber arrangement that you would have seen on a number of your other old structures to Greenslade Bridge. We did look at doing the full renewal to Greenslade Bridge, as in a civils element of renewal to remove the longitudinal timber element effectively, but in the timescales we had, wasn't possible, and the steelwork repair and the longitudinal timber replacement removed the TSR effectively.
Oh, that's great, thank you.
Just to add one thing, just to prove that track and drainage engineers do need to work together, the old span of Greenslade Bridge, Dan was referring to the fact that there were 2 tracks previously. On this side of the old, what would have been the down line, there's a 450mm cast iron drainage pipe that goes across the bridge. So not only would it have been more complicated, but there would have been a lot more thought about the drainage network, and whether that was the right solution. So there you go, track and drainage and civils do go together.
Okay, that's great. Mark, I was just going to say, Mark has mentioned that it's going to be renewed in the next couple of years. So will it then be renewed as a ballasted deck?
That's what the proposal is, yes.
All right, great, thank you.
Yeah. Yeah.
Okay, thank you. We can take one last question.
I think that was the last question.
If that was the last question, okay, that's great. Okay, so I'm going to bring this meeting to a close now. So I'd like to thank Mark and Dan for their very interesting presentation. The flagship project, for the route, for the region, not least because it was part of this new philosophy of delivering projects, in reduced timescale and reduced cost. And I think you articulated that very well today through this, what we call speed, and I can't remember what the acronym stands for, but...
Swift, pragmatic, effective, efficient delivery.
Thank you very much.
That's what we did.
Yeah, well, I also made the presentation was certainly there is partner as well. So, yeah, quite a big project itself. We said earlier, not that much about complexity into the project, but a big project nevertheless. 24,000 sleepers, 29,000 tons of ballast. I've not seen a tamper block it for 2 months. The track engineer myself, these figures, talk to me quite a lot. A flagship project also for local communities and local economies. These projects always are. I noted the reporting tool that you had, and I know some of the reporting went straight up to number 10 in London. So there was a lot of focus for the project, and you did deliver on time, or under time. I think it was said under budget, so well done for that. And to finish, Mark, report over drainage, is sort of critical, I think, to a good functional railways. And this was put actually on this project, and we saw us today certainly demonstrate that. So I'd like to finish this session by thanking Dan and Mark in the usual manner. Thank you very much.